This module started with a recap of what method overloading is and how that works. Method overloading is when two methods share the same name but have different parameters. We saw a few examples of this, both when the process method had an alternative overload as well as an extension method that provided a different overload. We then looked at a different type of overloading. You were introduced to the concept of operator overloading. C# contains a large amount of operators, and a lot of these can be overloaded. It's worth noting that many developers will go through their entire career without having to introduce operator overloading. Overloading an operator is done with a static method. The return type may be dictated by which operator you are overloading. You then introduce the operator keyword, followed by the operator, finally its required parameters. If you work in a solution where operator overloading is appropriate, it's wise to consult the Microsoft Docs to ensure that the operator is overloaded accordingly. Understanding operator overloading makes you appreciate the types that cleverly implement this. We saw an example with a datetime, where you could take two instances and subtract one from the other, and this would result in a completely different type, which represented the time span between these two dates. If you build complex mathematical types, introducing operator overloading is definitely going to be handy. You then saw how to use Visual Studio to generate equals, get hashcode, and the equality operators. Then we saw an example of the conversion operators. You learned that you can introduce an implicit or explicit conversion. This means you can introduce a method that lets you convert an instance of your type into anything else, as long as it's an appropriate conversion. If your conversion could lose data or throw an exception, you should implement the conversion using the explicit keyword. Finally, we looked at extension methods. If you want to add methods to an existing type, but you do not own that code or not allowed to modify it, using an extension method lets you add a method to a type just like if it was an instance method. This is a great way to create reusable code for common functionality on a given type. We saw this being used on an IEnumerable, but also on the order. Obviously, the order is a part of our solution, so you have to imagine that it's not. This could be coming from a shared domain library that was retrieved through the company NuGet server. An extension method lives in a static class, and the method signature need to follow a very basic pattern. It needs to be a static method, and the first parameter uses the this keyword to indicate the type it's adding a method to. While the static class could contain extensions for everything, it's wise to group your extension methods into classes that represent the type that you are extending. This will make your code more readable and maintainable. These methods will show up as instance methods on the type itself. You could call these methods explicitly by simply using the class name dot the method and pass the parameters, just like any normal static method call. It's important to remember that the compiler will see the extension methods as the lowest possible priority. This means if there's a method on the actual type that has the same signature as the extension method, it would never call the extension method. This may happen in situations where you previously extended a type with functionality and then someone updated the type with a similar method signature. We looked at what is probably one of the most commonly used extension method libraries out there. This is system.link. It provides an extreme amount of extensions to IEnumerable and other types as well. This will let you work with collections of data in a much more pleasant manner. There's a whole lot more to LINQ than what we've looked at in this course. It's a powerful set of extension methods, and it shows exactly what this language feature was built for. With collections in mind, I'd like you to think about the following. When you filter through a collection, or only want to select a subset of the properties available on the type, it would be really handy if there was a way to create a tiny representation of only the data that you want to use. Creating a class that will only represent the order number and sum, for example, may seem excessive, especially if this container of data will only be used inside the current method. In the next module, we'll be looking at what's known as an anonymous type.